So anyway, I mean, that's why, I mean, I try to make it as personal as possible uh, by giving you all my contact details. So I send you several emails to you guys, giving you all my contact details. I assume you have, including my home phone number, Skype address, Zoom address, email address, everything. So please feel free to contact me 24/7, whatever problem you have. With this course or any other issue that is bothering you, please feel free to contact me. All right, as far as this course is concerned, um, there are two things that I need to talk about. One is the website. So let me show you. Um, Let me show you the website. The website, I assume that most of you know the website. This is the website for the course, right? If you don't know where it is, this is the address. This is the address for the website, right? Can you see this, guys, or no? Okay, this is the web address for the course website. By the way, I do not use Blackboard because I find it really annoying. So I prefer to use this website because this is freely, you can access it from anywhere without login, without having to log in, right? So there is a course syllabus. This is the course syllabus. It gives you the timetable for every week. So this is week 1, week 2, etc. So it gives you the time of the review session, which is the one right now, and the time of the tutorial, and also the tutorial sheet for every week, right? And these are details about me. I'm sure all of you know this. And this is description, learning outcomes, and so on. And then as far as assessment is concerned, there will be quizzes every week, not this week though. So the first quiz will be due on the 10th of November, 12 noon. So there will be quizzes starting from the 10th till the 19th of January next year. There will be quizzes every week, right? And each quiz is worth 1 mark, right? So the 10 quizzes will be worth 10 marks. And there will be an in-class test on the 15th of December. And the formulas you need to know for the test are listed in this link. So this is the link that gives you the formulas you need to remember, which are not really difficult. And then the final exam it will be in January 2021. And the formulas you need to remember for that exam are in this link, right? All right, so the quizzes, the 10 quizzes will be worth 10 marks. The test will be worth 10 marks, and the exam will be worth 80 marks, right? So that makes up 100%, right? And these are right, let me go back to the website. So this is, so these are the formulas that I just referred to. Right, now in the website, I kind of broken up the website into different weeks. So this is the preliminary material you need to know. Yeah. And this is the week 1 material. This is the week 1 material you need to know. Like, so these are the 4 videos I asked you to listen to before coming to this class. I hope most of you have listened to these 4 videos. The video on welcome, the video giving the motivation, the video giving the 3 definitions of extreme value, and the video talking about the distribution of extreme value under definition 1, right? And you also have the handwritten notes for each video. So these are the notes, mostly handwritten notes. Some of them are typed, but these are, I hope you can read my writing. If you cannot read my writing, let me know. I will try to write better next time. Okay. And then the tutorial is on Thursday, 2 to 3 p.m. Right, guys. And this is the sheet for the tutorial. There are 4 questions. There are 4 questions for this tutorial. Okay. And after the tutorial, I will post the solutions. There will be 4 kinds of solutions. There will be typed solutions. There will be handwritten solutions. There will be podcasted solutions. There will also be video solutions. So I've taken my time. Hello, guys. Are you listening? I've taken my time to produce 4 different solutions for each tutorial sheet. All right. So I hope you appreciate that. So that's for week 1. This is for week 2. For next week, you will need to listen to these videos, right? And the tutorial will be based on this sheet here, right? And week 3, you have this. Week 4, you have this, and so on until week 11, okay? And then you have this section called supplementary notes. The supplementary notes gives you notes, like if you want to learn stuff that is more than what we learn in this course, you can read this. Like for example, if you look at chapter 1, this gives you a lot more material, than what I actually teach you as part of the handwritten notes, right? So if you want to read more about extreme value theory, you can read this stuff here, right? It gives you a lot more material. It's all typed up, right? It's all typed up. So it's, and similarly chapter 2 and so on, right? But there's no need to, I'm not asking, because it's not going to be examined. So the only thing that's going to be examined is the stuff I put under every week, right? Like week 1, week 2, week 3, etc. But this stuff is supplementary. It's like if you want to learn more about the stuff I'm teaching, right? These are quizzes from 2018-19. These are quizzes and solutions from 2019-20. And these are the quizzes for this year. So the first quiz is this one. So this is due on the 10th of November. I think it's 2 weeks from today. So you can write down your solutions and email it to me, right? And then I will mark all the work on the same days, and I will return your marked work as well as the typed solutions, as well as feedback on the same day, right? So you will get your results on the 10th of November, right? Okay, so that's the quizzes for this year. Then the in-class test and solutions for the last several years, right? And these are exam papers and solutions for the last several years, right? So this is the website, right? And by the way, these are the books. Some people ask me where the books are, but I already put them over here. So I don't know where you were looking. I don't know. Maybe you were not looking at the right place or something. These are the free books. There are 5 books I have downloaded and uploaded them to this website. So this is the first book, Modeling of Extreme Events for Insurance and Finance. This is the second book. This is Springer is called Extremes and Related Properties of Random Sequences and Processes. And This is the third book. So, I mean, extreme values, regular variation, and point processes. So if you want to know more about the stuff I'm teaching you, you can read these books. There are 5 of them, right? And if you want me to download other books which are not here, I'm happy to do that. So if you think there are other books on extremes that you like me to post on this website, please let me know. Okay. All right, guys. So that's the there's one person asked me, how do we submit the quizzes? You can submit the quizzes by email, guys. You just write them on a piece of paper and scan them and email them to me. That's the easiest way to do it, I guess. All right. All right. Now the next thing I want to show you is the YouTube channel. So I created this channel for extreme values and financial risk, right? So there is a playlist for every week. For every week, I have a playlist. So if you look at this one here, this is the playlist for. Sorry. If you look at this, all right. This is in this video. I'm going to talk about. All right. This is the playlist for preliminary material, right? Okay. All right, and then this is the playlist for week 1 material, right? And then the same thing for week 2. I'm trying to find where it is. Yeah, this is the playlist for week 2 material, and so on. So what I usually do is I ask you to watch the playlist before coming to this class, and if you have questions on the playlist, right? If you have questions with that I mean, stuff that was not clear on the playlist, then you can ask me during this session, right? Okay. So those are so it's just the only thing you need to know is the YouTube channel and the course website, which I showed you a few minutes ago, right? So, oh, sorry, what am I doing? So just the course website, which is this one, and the YouTube channel. That's all you need to know, right? You have any questions so far? You want any questions you have so far? You want to ask me? Hello, guys. Talk to me. Is everything okay so far or not? Hello, guys. Yeah, good. All right, now I'm gonna switch to, I don't know whether you can see this. This is the first time I'm using this. Oh, sorry, I'm trying to test the visualizer. All right, here we are. Can you see my writing or not? Hello. Can you see my writing? Yes. Okay. I'm just trying to test if this is working or not. Okay. So I just want to summarize what is in the videos in the next whatever 45 minutes I have here. I want to summarize what I talked about in the in the 4 videos, right? Okay. So the first thing I want to talk about is this one. If you cannot see this, please let me know. I don't know whether it's clear because my eyesight is very bad, so I can't see it very clearly. I mean, to be honest. But if you can see it, let me know if it's okay. Let me know. Okay. So this is the definition of. There are 3 definitions of extreme value, and this graph here corresponds to definition 1. Definition 1 of extreme value, right? Oh, it's not so clear. Oh shit, man. Trying to figure out how to make this clear. No. I'm trying to make it clearer, but can you see it better now or no? Or is it still bad? Is it still bad or is it still better or not? A little blurry. Just give me a sec, okay? Give me a sec. Hello guys, just wait a minute. I'm trying to fix this problem. Just give me a sec, okay? I'm just trying to fix this problem. Is it focusing okay now?
Yeah. We need to go exactly.
Okay. All right. Okay, guys. All right. Can you see it? All right. It looks better right now. I'm sorry. Is it all right? Oh, I think yeah. It looks good now. Okay. Thank you, guys. Right. So this is definition 1 of extreme value. So which is where you take the extreme value as the largest data point over a period of time. So in this case, suppose you have temperature data in Manchester, so you have 365 data points in a year. So this would correspond to the largest temperature in a year recorded in Manchester, right? So this is definition 1. And definition 2 is this one. This is definition 2. So instead of looking at the largest data point, you draw a line across the data, right? And see if if any data point that exceeds this line is considered an extreme value. So for example, if this is the temperature data, suppose this line corresponds to say 30 centigrade. I mean, 30 centigrade in Manchester is pretty extreme, right? I mean, it hardly gets above 30 centigrade in Manchester. So anything above 30 centigrade can be considered an extreme value, right? So in this case, in this plot, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11 extreme values in a year, right? So that's definition 2. And definition 3 of extreme value is this one. Instead of picking the largest data point, which is this one, you also pick the first few largest. So in this case, you pick the second largest, the third largest, the fourth largest, and the fifth largest, right? So this is known as the definition 3 of extreme value. And then, all right, for the moment, in the videos for week 1, in the videos for week 1, I talked about definition 1, right? So suppose so let's consider definition 1. Suppose you have data, say x1 to xn, IID. IID means independent and identically distributed with CDF-F, right? Right, then under definition 1, the extreme value is the largest data point. So right, is the largest data point. So I use this notation to denote an extreme value, right? This is right. Now, the first thing you want to do in order to make predictions or estimation, you need to be able to find the distribution of this. So the CDF of MN is computed as this. Which is the probability that the maximum right? Now, if the maximum is less than or equal to x, then every single one of these has to be less, right? So okay. Now, because we are assuming that x1 to xn are IID, right? We can say that because of using independence, using the fact these are independent, we can write this as x1. Right. Okay. Right, and this, because we said earlier that the CDF is F, that means that this guy here has to be F of X, and this guy here has to be F of X too, right? So what you have is F of X power n, right? Okay, so this is the distribution function of the extreme value Mn, right? But people are usually interested in what happens to the distribution as n goes to infinity. N is a sample size. So for example, in 1 year, you have If you're recording daily observations, n will be 365. But people are not just interested in 1 year, but they want to know what happens over a long period of time. So it could be 10 years or 20 years or 50 years. So n is going to be a pretty large number over that period, right? So they want to know what happens to this distribution as n goes to infinity. So as n goes to infinity, the limit of the probability that mn, yeah, is going to be the limit of n goes to infinity of this. Yeah. Now, because I'm sure you know from first year that any CDF must take a value between 0 and 1, right? So the limit will be 0 if fx is 1, and it will be equal to 1 if fx equal to 1. So if it is less than 1, guys, if it is less than 1, remember, if you raise a number that is smaller than 1 to the power n and take n to infinity, then it will be 0. Whereas if fx equal to 1, oh, sorry. Thank you for letting me know. All right. If fx equal to 1, then 1 to the power anything is 1, right? Okay. Okay, so the limit of this distribution of extreme value under definition 1 is either 0 or 1, which is not something very useful. This is not something very useful, guys. All right. All right. So the thing what we need to do is to come up with a result that is more useful, and this is where the parallel to central limit theorem comes in. Now, all right, let me show you. This is where you remember that this is now suppose we have x1 to xn from a population, right, with expectation of x equal to mu and a variance of x equal to sigma squared. Now, let x bar denote the average, the sample mean, right? Now, I'm sure you guys know, tell me if you don't know, that if you look at the limit, of x bar as n goes to infinity, then this is equal to the population mean. I mean, this result is known as the strong law of large numbers. Strong law of large numbers, right? And this result is not very useful because it says that the limiting distribution or the limit of the sample mean is a fixed number, which is the population mean. So it's not a very useful result, as you can see. But you can make this into something very useful, and that, so to make this into something useful, we have this result here. That is, instead of looking at the limit of x bar, we look at a normalized version of the limit, right? And this, I'm sure all of you know, approaches the standard normal distribution as n goes to infinity. Right, and this is obviously known as the CLT, or the central limit theorem. Right. So you see what we have done. We have turned this result here. We have turned this result, which is not a useful result, into something which is a useful result. Obviously, the central limit theorem, as you know, is applied in every area of, in every area of the sciences and engineering, central limit theorem is applied. So we turned this into this, right? And that's what I'm going to do here, because that's what that's what we're going to do with extremes, right? Instead of looking at the limit of this probability, which gives you this, which is not very useful, right? You look at the limit of a scaled version of this probability, right? Just like here, we look at the limit of the scaled version. So we are scaling by a constant mu and dividing by another constant, this, right? Okay. So in the next page, we look at the scaled version, which is the mn minus bn divided by an. So just like we scaled the x bar, the sample mean, here we are scaling the sample maximum, where an and bn are certain constants, right? Okay, and you should do the calculations. You should do the calculation that the CDF of the scaled version is as follows. So I'm going to look at okay. So this is going to be the probability that mn is less than or equal to anx plus bn, right? Okay. So this will be, excuse me, this will be the probability that the maximum of x1 to xn is less than or equal to anx plus bn. Now, if the maximum is less, then each of the x's has to be less, right? So it's the same as saying that x1 is less than or equal to okay, right? And we know that by independence, because x1, we are assuming that x1 to xn are independent. Oh, somebody is waiting. Sorry. Excuse me. Yeah, thank you. So, but because of independence, we can write this as yes. And we know that the CDF of x1 to xn, each of them have CDF equal to capital F. So this would be F at an x plus bn. and this would be f at ANX plus BN, right? And these are the same, so this would be equal to right. So you see that I have shown that the distribution function of the scaled version is equal to this, right? Well, yeah, one person just asked me, where do we find AN and BN from? Yeah, that's a good question. The AN and the BN, I will give you formulas later on in the course. I think it's in week 2. If you look at week 2 videos, there are formulas for working out AN and BN. Okay, so I will talk about them next week. All right, but for this week, just be happy with what you have. So just for this week, this is the probability distribution of this. The cumulative distribution function of this is equal to this. And the next, what we will talk about next week is you want to find the limit of this, right? So what is, the question is, what is the limit as n approaches infinity, right? That's the question. That's the question we will ask next week. The limit of this. In other words, if you take the limit of ANX plus BN to the power n as n goes to infinity, what would that be equal to? And the answer to this question is in the videos for week 2. So when you have time, guys, can you, before next week, before next Tuesday, right, try to watch the videos for week 2, right? They are, you know, the YouTube channel where they are, yeah. So if let me, by the way, do you have anybody has any questions on what I have written so far? Before I go to the YouTube channel. Any questions so far, guys? Talk to me, guys, please. Yes, no? Come on, guys. All right.
No, thank you.
So far, so good. Okay, thank you. All right. So let me go back to let me go to the other one. Sorry, excuse me. Change the camera. All right, here we are. Okay. Now let me go to share screen and show you the YouTube channel. So if you go to the YouTube channel, if you look at week 2 videos, these are week 2, right? So these are the five videos I would like you to watch before Tuesday next week. So there's a video on extremal types theorem. There's a video on conditions for extremal types theorem. There's a video for alternative conditions for extremal types theorem. And there's a video on formulas for norming constants. This is the question that one of you guys asked me now. So this video here gives you the formulas for AN and BN, which are the norming constants, right? And finally, there's an example where the extremal types theorem fails to hold, right? So I would like you to watch these 5 videos by next Tuesday, right? And also email me all the questions you have that you don't understand about these videos. so that when I see you guys next Tuesday, I will answer those questions. Even before that, I will answer the questions, right? All right, guys. Now, any questions you have right now? You okay? Are you sure? All right. All right. Next, there's one question that one person asked me a few days ago. Is that let me change the camera. One person asked me that. All right, here we are. Okay, so far, I mean, in the definitions of the extreme value, right? In the three definitions of extreme value. So, for example, you should go back to you should go to definition 1. This is definition 1 of extreme value, right? I looked at only at the maximum, the largest point of the data, right? But the extreme value can also be defined to be the minimum. So instead of looking at the maximum, you can also look at the minimum of the data point. That is also an extreme value, right? Right. So, but the reason is that I have chosen to do the maximum because it's easier to deal with than the minimum, right? But the same theory, whatever we learn in this course, will also apply to the minimum, right? You follow what I'm saying? So the reason I've chosen this one and not this one is because it's easier to do the calculations for the maximum, right? But the same theory, theory will apply to the minimum too. Okay. Right. All right. So so that's the only question that's one of the questions I heard from one of you. If you have other questions, please let me know. So how's your other courses going? Okay so far? Any problems? Like everything cool? Yeah. All right, good. So let me so going back to gamma function. Yeah, there's no need to know the proof for the gamma function. So you should I mean I have given a lot of material. You should go to the the course web page. There are a lot of stuff in there, but I don't expect you to prove anything unless I ask you to do so. Right? So I mean there are. Let me go back to the course website. Right, like this like stuff on in the preliminary material. I'm sure all of you know this gamma function. There's a this is the definition of the gamma function, and these are some properties of the gamma function. I don't expect you to prove them. If you can prove them, that's fine. I mean, I don't. These are some properties of the gamma function. And similarly, this is the definition of the beta function. This is the definition of the beta function, and these are some properties of beta function. Again, I don't expect you to prove this. And this one is a differentiation trick. You will need to know this for this course, right? This is the trick on differentiation. And this is the product rule for different. I'm sure all of you know this. This is when you have product of two functions. This is the rule for differentiation. This is when you have a product of three functions. This is the rule. And when you have a product of n functions, this is the rule for differentiation, right? And then the L'Hopital's rule. I'm sure all of you know the L'Hopital's rule. You will need to use this in this course, right? So it just says the limit of the ratio is the same as the limit of the ratio of the derivatives, right? Okay, that's the L'Hopital's rule. All right. So I don't expect you to prove anything unless I will say specifically which things you need to prove and which you don't need to prove, right? Okay, guys. So on Thursday, we have a class on Thursday from 2 to 3. The tutorial sheet for Thursday is this one, right? So try to, I mean, these are pretty straightforward questions. You shouldn't have any difficulties. So try to go through this if you have time before that. So please try and do at least the easy ones. The question 1 and question 4 are easy. All right, so please try to do that. Okay. All right. Any? Well, there are some. Do we have to remember the gamma function and the beta function? Well, it depends on what you're asked to remember. Yes, like for the exam, and also for the in-class test, there are certain formulas I will ask you to remember. Right. So, for example, if you let me go back to this. Like if you go to the top of this page, right, and if you look at the formulas you need to remember for the exam, these are the formulas you need to remember for the test. Sorry, for the test. So it doesn't include the gamma function or the beta function. So you don't need to know them, right? And for the exam, these are the formulas you need to remember for the exam. And again, I'm not sure whether this includes the gamma or the beta function, but it doesn't look like it is included, right? So you don't need to know them. So I mean, if the gamma and the beta function are going to appear, then I will let you know, and you will need to remember them. But otherwise, you do not need to remember them. And for the tutorial sheet this week, which is this one, yeah. I mean, you don't need to derive the MLE in closed form. As long as you leave the MLE as a root of an equation, that is fine. I mean, you don't need to derive the maximum likelihood estimator as a closed form expression. You just need to leave it as a solution of an equation. If you can do that, that's fine, right? Okay. Anyway, after the class on Thursday, I will give you the solutions, the full solutions. All right, guys. So you only need to, you don't, I mean, for the questions, the 4 questions on the MLE, you just need to give the equations. You don't need to solve the equations if you cannot. I mean, you just need to give the equations for which the MLE is a solution. Okay. All right, guys. Any other questions, guys? Yeah. So, I mean, as I said, like, I like to, although this is a very difficult time for everyone, I mean, especially for you guys, I like to keep like a personal contact between you guys and me. That is why I have given you all the contact details, like including my home phone number. So you can call me any emergency or anything that is bothering you that you like to talk to me about. You can call me 24/7. You can Skype me 24/7, Zoom 24/7, or email 24/7. I'm also happy to see you in person 24/7. Like I live very close to the uni. I'm only like 10 minutes walk from ATB, right? So anything you want to see, like if you want to see me about something, I'm happy to do that 24/7, right? Okay, guys. So anyway, as I said, like this is very difficult time to everybody. So, but for that reason, I like to keep, you know, the contact with you personal, so that you don't feel left out, you know, by things that are going around. Okay. All right. One person asked me which definition is most used in practice. That's really difficult to answer, but I guess the most used are definitions 1 and 2. Definition 1 and 2 are the most used uh, in practice. So definition 3 is not so much. It's not so much used. So yeah, definition 1 is the most used. Yeah, 1 and 2. Yeah. All right, guys. Any other questions? All right, guys. So I hope all are well with you, and I hope that all your courses are going okay. All the other courses that you're taking right now. Okay, and all right, so um, I will talk to you guys again on Thursday. So don't forget, I think it's at 2. Is it right? 2 to 3 p.m. Yeah. So please log in by 2 p.m. on Thursday this week. All right. So have a good evening. I will talk to you again soon. And again, whatever problem you have, please feel free to contact me 24/7. Right. I've given you all the contact details. Right. Okay. Bye, guys.